Hi Pirates, I hope you're having fun with Chapter 4. Today we're going to talk about the difference in ways to justify. So the two different ways are going to depend on what does the question ask us to do. So for this first question, we're asked to find absolute extrema on a closed interval. So when it says justify, the way in which we're going to do that is to make a table. Our table includes all the possible critical values. So critical values happen first at the endpoints. So I have a -3 and a 5. When I plug those into my original, I get 8 and I get 80/3. Okay, where else do critical values happen? That's right, they happen at the derivative. So when all else fails, I should definitely take a derivative. I've mastered my Chapter 3 rules. My derivative is x squared minus 4. So I want to ask myself, when does the derivative equal 0? If I set this equal to 0, I get plus or minus 2. Is my derivative ever undefined, does not exist? Nope, nopey, nope. So that's not going to bring any critical values to the graph. Okay, so I checked that -2 and 2 are in my interval. Again, points come from the original. So I plug them into the original. I get 31/3. And when I plug in 2, if I'm not mistaken, I get -1/3. Maybe double check my calculation there. When you're answering an absolute extrema question, your answer is going to look like a phrase. So I survey the situation. I have an absolute minimum of -1/3 at x equals 2. I have an absolute maximum of 80/3 at x equals 5. So again, my critical values come from 3 different places. My answer looks like a phrase. All right, moving right along, we have a different kind of question that asks for the relative extrema. This means we don't absolutely know if they're the max or the min. There's no closed interval. Okay, that's another clue. It's a clue. There's no A and no B. I still need to investigate the derivative. So this is where I think about my derivative sign chart. My critical values from my derivative were at -2 and 2. If I were to take, let's say, 0 and plug it into the derivative, I would have a negative value. If I were to plug in -3, I would have a positive, and anything bigger than 2 would also give me positive. When all else fails, I should probably also take a second derivative. I'm actually going to write that down here just so we have it listed. My second derivative, not too shabby, is going to be 2x, and that has a critical value at 0. If I have a negative number, my second derivative would be negative. If I had a positive, that would be positive. Okay, so let's investigate our first derivative sign chart. If my first derivative is positive, my original was increasing, then my original was decreasing, and then my original was increasing. We did this way back when we started investigating derivatives. So it looks like at -2 we have a maximum. So I have a max at x equals -2. I feel that way because the first derivative is 0. The first derivative in general was greater than 0 to the left, and the first derivative in general was less than 0 to the right. Now please be careful with the details. We need a value in here, x is here, intervals here. Okay, at +2, I have a minimum. Again, I don't really know if it's absolute or relative because I don't have endpoints. I'm not justifying with the table. I feel this way because my first derivative is 0. My first derivative in general was less than 0 on the interval to the left and greater than 0 on the interval to the right. This is what our justification looks like when we are using what's called the first derivative test. Now, what's sometimes confusing, the second derivative test is really a combo of both the first and second derivative information. It's the same answers. This is not a new function. It does not have a new max and a min. Unfortunately, some of you are probably going to give me different answers. Please don't be that someone. Let that someone be in some other class. So I still have a max at -2. My feelings have changed. I feel this way because the first derivative is 0, but now let's think about a maximum. If I draw a maximum, I have a horizontal tangent, and then my second derivative at -2 would be negative because I'm concave down like a frown. My minimum, similarly, would now be concave up. So my first derivative would be 0, and my second derivative would be positive. Notice there are no intervals involved in the second derivative test. For both of them, it just, what you see is what you get. All right, we're almost done, friends. Last but not least, we want a point of inflection. A point of inflection comes from the second derivative equaling 0, changing signs. We didn't have any discontinuities, so that's not an issue. My second derivative is 0 at 0, so I feel good that I have a point of inflection at x equals 0. This justification will resemble the first derivative test with the second derivative sign chart. So second derivative in general is less than 0 on the interval to the left and greater than 0 on the interval to the right. It doesn't matter if it goes positive, negative, negative, positive, as long as there's a sign change and this value exists on the original. Happy justifying! I hope to see you all soon.